Good afternoon, students. In today's class, I'm going to discuss about what do you mean by leftmost derivation and what do you mean by rightmost derivation. Right here in left, generally any grammar is consisting of 5 tuple g equals to vtps. V is the set of variables, t is the set of terminals, p is the set of production, s is the starting symbol. Right here generally variables are going to represent by the capital letters, terminals are going to represent by the small letters, productions are going to define here, productions are going to be defined here. S is the starting symbol. Whenever we are going to derive any tree, we have to start with the starting symbol. We have to start with the starting symbol. Right here, derivation t or parse tree means here we are going to represent this syntactically. We are going to represent by the productions. Right here, now we can, for a given stream we can derive a derivation tree. For a given stream we can derive a derivation tree. Here whenever we are going to derive any derivation tree, we are going to use the leftmost derivation and the rightmost derivation. We are going to use the leftmost derivation and the rightmost derivation. Here in leftmost derivation, here generally leftmost derivation is obtaining by applying the productions to the leftmost variable in each step. Here generally leftmost variable is going to represented, leftmost variable is going to be replaced in leftmost derivation. Right, whereas in case of rightmost derivation, rightmost variable is going to be replaced, rightmost variable is going to be replaced. Right, see here, see here in this case, see here, ss is there. Right, this s is there, this this is the leftmost variable, this is the rightmost variable. See here, here first I am going to replacing this s by this asb. So left, first I am going to replacing this left s by asb. Then here, then we are going to replacing this s. So here while we are going to derive any derivation tree, we can replace any variable, we can replace any variable, either left side variable or right side variable. But whereas whenever we are going to deriving the right this one leftmost derivation tree, we have to replace the leftmost variable only. Whereas in case of rightmost derivation, we have to replace the rightmost variable only. We have to replace the rightmost variable only. Right, right. Now here for example, here just I am going to deriving the leftmost derivation tree. Just I am going to deriving the leftmost derivation tree. See here, this is my production, this is my production. Let x, let any set of production rules in cfg is x tends to x plus x, x star x s over the alphabet a. Now here in this case, here how many productions are there here? Here how many productions are there here? Here x tends to x plus x is one production, x tends to x star x is one production, x tends to x is one production, x tends to a is one production. This grammar is consisting of v. How many variables are there? Only one variable is there, that is x. How many terminals are there? Here we are having only one terminal, that is here we are having the terminals are a plus and star. These three are the terminals. Here productions are, these four are the productions. Now which one is the starting symbol? X is the starting symbol, x is the starting symbol, x is the starting symbol. Right, now here, here check my string. What is my string? Here my string is a plus a star a. This is my string, a plus a star a. So here I can take either this production, I can take either this production. I can't take this production. Why? Because here my output string is a plus a star a. If I am going to take this s x only here, we can take this x also. After taking this x also, we can take x plus x or anything. You can take any production. By using that production, you have to generate this string. Right, you have to generate this string. For example, here I am going to take here, see here x plus a, he is taking x plus a now. So here my string is x tends to x plus x. Right, x plus x. Right, here what is the string? At the end, what is the string a plus a star a? Here my string is a plus a star a. This is my string a plus star a. So here first step is x tends to x plus x. Now here x tends to this x, we can replace this x by, here for example here a is there now, so here I am going to replacing this x by a. See here leftmost variable is going to replace first, leftmost variable is going to replace first, that's the reason here, yeah, I am going to replacing this x by a. See every time you have to concentrate in the on the output string, you have to concentrate on the output string. Now here what is my output string? A plus a star a. Now a plus, instead of this x, I can represent this x star x, right? We can replace this x by x star x. Okay, I am going to replacing with this x star x, right? Now here my variables are a plus x star x, right? Here I am having two variables, this is one variable, this is second variable, so I have to replace the leftmost variable first, I have to replace this variable first. So x tends to a plus, here a star x, right? Now x equals to a plus a star. Now replace this x by a, replace this x by a. So I am getting my string a plus a star a. So this is a plus a star a. So here first what is my string? X tends to x plus x. See here in step 1, here now I am going to draw the derivation tree for this leftmost derivation. Here see here in this given example, every time we are replacing this leftmost variable only, we are replacing the leftmost variable only. X is x, x plus x. See here this derivation is there now, derivation is there, x equals to x plus x. So here first x, initial symbol x plus x. In step 2 we are replacing this x by a, we are replacing this x by a. So here we have to x, already this is there, now this x is going to replacing with a, right? In third step this x is going to replacing with this, right? Third step we are replacing this x, x star x. See here already x, x plus x. Here now this x is going to replacing by this one x star x, this x is replacing with x star x. Now see here, now in this case which one is this one? Here we are replacing this x by a, we are replacing this x by a. See here I am replacing this x by a, x star a. Next I am then here see here a. In next step I am replacing this x by a, so next step I am replacing this x by a. So this is the leftmost derivation for the same tree, this is the leftmost derivation for this given tree, right? Here this is the, here in leftmost derivation every time we are going to replacing, every time we are going to replacing with this leftmost variable, right? See here I am going to take one more example. Here consider the grammar with the productions, consider the grammar with the productions. G equals to SAB, A comma B, P comma S with the productions. S tends to A B, A tends to B B B B, B tends to A and epsilon, B tends to A and epsilon. My string is A B B B B. Now here, what are my productions here now? I'll take this one. Just wait, I'll copy this one. Start. I'll copy this thing, Control C, Control V. So this is my string. S tends to A and B. Here A tends to B, 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 B tends to A. My string is A, B, 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 B. Now here, which one is the starting symbol? Starting symbol is S. So here S tends to, I am going to write here. Sorry. Here S tends to A B, right? S tends to A B. Now Here, how many variables are there here in this case? There are two variables are there, a and b, two variables are there. Here we are going to draw the leftmost derivation. That's the reason we have to take this, we have to replace this a, right? So s tends to, s tends to a. For this a, we are going to write b, b, b. A is b, b, b here, right? Next is b. Right. Now, next step. Here again two symbols are, two variables are there. This is one variable, this is the second variable. Now we have to take the leftmost variable, that is leftmost. What is the leftmost variable here? This is the leftmost variable here. So we have to replace this one. So s tends to a, b. For this b, again I am going to replacing this b by a, b, b, right? Now here again how many variables are there? This is a and this is b, this is a and this is b. So I am going to replacing this, s tends to a, b. A is there, so I am replacing this a with b, b, b. Remaining b is there, b, b is there, this b is there, again b is there. So here my string is b, 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 b. See here a, b, 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 b. So these two variables are there, this b is there, this b is there. So I am going to replacing this, these two are the variable. Now I am going to replacing the firstmost variable by epsilon. So s tends to a, b, b, epsilon, b, 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 right? Now here again, here in this case we are having only one variable, that is b. So we have to replace this b by epsilon. Epsilon means null string. S tends to a, b, 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 epsilon, right? Now s tends to a, b, 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 b. So this is our the required string, this is our required string. S tends to a, b, 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 right? Now I am going to draw the derivation tree for this one. Here first one, what is the first step? In first step, here this is the first step, I am going to write here first. Now first step, in first step here s is there, s, then small a, then capital A, then B, right? Yeah, A, B. Next, this A is going to represent by B, B, B. So in step 2, that particular A is going to represent by S, right? This A. Now this A is going to represent by, this A is going to represent by B, B, B. A is going to represent by B, B, B. B, 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 right? Next. Now this B is going to represent by this A. B is going, in step 3, B is going to represent by this A, right? S, A, S, A, S, B, again B, this B, B. This B is going to be represented by, this B is going to represent by this A, right? This is this third step. This B is going to represent by this A, right? Now step 4. What is step 4? This A is going to represent by B, B, B. A is going to represent by B, B, B. So S, A, A, B, right? S, B, 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 then this A is going to be represented by, this A is going to represent by which one? B, 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 right? Now, fifth step. In fifth step, how you are going to write this one in fifth step? Here, this B is going to, see here, this B is going to represent by the epsilon. B is going to represent by this epsilon. First S, then A, then A, then B, right? Then A is going to represent by this B, 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 then it is going to represent by this A, then it is going to represent by this B, 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 then B is going to represent by this epsilon. B is going to represent by this epsilon. Now, sixth one, right? Sixth one. Now, here, now this B is going to be represented by this epsilon, right? B is going to represent by this epsilon. So, that is six steps. S tends to A, then A, then B, then A tends to B, 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 then this B tends to A, then this A tends to B, 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 then B tends to epsilon, right? What is the last step? This B tends to epsilon. This B tends to epsilon. And this B tends to epsilon. See here. Now, we have to take this leaf nodes. See here. This is one leaf node, right? This is one leaf node, right? This is one leaf node. See here, epsilon is there, we have to leave that particular epsilon. Epsilon means that is the null string. This is B node. This is also our B node. All the leaf nodes must be the terminus. Here this is the epsilon, so we have to stop this one. So, what is our string? A, B, B, B. Here, A, B, 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 B. 4 B's. So, this is my leftmost derivation. This is my leftmost derivation for the given string. This is my leftmost derivation for the given string, right? See, next. Now, up to here clear? Now, we are going to same. Rightmost derivation means we have to derive from the rightmost variable. We have to derive from the rightmost variable. Here in the previous cases, every time leftmost variable is going to be, every time leftmost variable is going to be replaced, whereas in case of rightmost derivation, every time rightmost variable is going to be replaced. See here, same. Let x let any set of production CFG over the given alphabet, right? Here, see here, my productions are, I'll take this blue one. My productions are, see here, what are my productions? X tends to x plus x, or x tends to x star x, or x tends to x, or x tends to a. These are all my productions, right? Here, what is my string? String is a plus a star a. My string is yeah, a plus a star a plus a star a. So here first I am going to take here, I'll take this blue one. First I am going to take one expression, that is x tends to x star x. X tends to x star x. Here, this is the leftmost x, this is the rightmost x. In rightmost derivation, we have to take the rightmost variable. We have to replace the rightmost variable first. So I am going to replacing this x by a. So every time we have to concentrate that string is a plus a star a. X star a. X star a. Now here only one variable is there. I am going to replacing this x by x plus a. So x tends to x plus x star a. X tends to x plus x star a. Now here how many variables are there? This one is the first x, this is one the second x. So we have to replace this x first. So x equals to x plus a star a. Right, now this x, now only we are having only one variable, that is this x. So I am going to replacing this x by a. X equals to a plus a star a. A plus a star a. See here first, x tends to x star x, x tends to x star x is there. Now here this x is going to replace by a. See here, this x is going to replace by this a. Next, here next is what is this? This x is going to replace with x plus x. See here, this x is going to replace with x plus x. X plus x. Next, here this x is going to replace by a. See, this is x is going to replace by this a. Next, this x is going to replace by a. X is going to replace with a. Now what is my string now? What is my string now? Here string is, my string is a plus a star a. Check this terminal. See here, this is a. So this is a, then this is star, then again this is a, this is star, this is a. My string a plus a star a plus a star a. So this is my strings, a plus a star a, right? This is the stepwise derivation for the rightmost derivation for the tree. Now next is, we will take one more example. Here previously we have taken this example na. Just I'll take this complete thing here, control C, control yeah, I'll take this example. Yeah, this is my string s tends to, yeah, s tends to a b, b tends, a tends to a b b, b tends to a and epsilon. My string is a b b b. Now see here, in this case I am going to replacing, I am going to deriving the derivation tree. I am going to deriving the derivation tree here. Here which one is the starting symbol here? S tends to, yeah, starting symbol is s tends to a B. In rightmost derivation, every time rightmost variable is going to replace. So I am going to replacing this b. So first step, s tends to a a. This b is going to replace by this a. B is going to replace by this a. Right, now s tends to a a. This a is going to replace by this b b b. A is going to replace by this b b b. Right, now this is the, in this case how many variables are there? This is one variable, this is one other variable. Which one is the rightmost variable? B is the rightmost variable. I am going to replacing this b by epsilon. I am going to replacing this b by epsilon. So s tends to a b epsilon b. Now my string is a b b. I am having one variable, only a is the one variable. Now I am going to replacing this a with b b b. So s tends to a b b b b. right? Now see here, this now only one variable is there, this is going to replace by this epsilon. So I'll get my expected string a b epsilon b b b. Now what is my string? S tends to a b b b b. This is my this string. So here by using this rightmost derivation I am getting the string a b b b b. Now I am going to draw the derivation tree. What is my first step? Here my first step is S tends to here a, yeah, this a, this b. Now this b is going to, in step 2 this b is going to replacing with which one? By a. So step 2 b is going to replace by this a, this capital A, this b, this a, right? In step 3, right? In step 3 what we are going to do here? This a is going to replaced by b b b, right? This a is going to replaced by b b b. S a a, this b, this a is going to replaced by this b b b, right? Now this b is going to replaced with, then this b is going to replaced by this epsilon. B is going to replace by this epsilon in fourth step, step 4, right? S a a b, this b is going to replace by this a, this a is going to replace with b, this b, this b, b is going to replace by this epsilon. Now which one is there? Now this a is going to replace with b b b. Now in step 5, this one S, right? A, this a, then b, b is going to replace by this a is going to replace with b b b, then epsilon, right? Then a is going to replace with b, capital B, and terminal B, right? In sixth step this b is going to replace with the epsilon. In sixth step b is going to replace by this epsilon. So S, right? Is a, then a, then b, b is going to replace with a, then a is going to replace with b b, this b, right? This b is going to be replaced with epsilon, right? Now a is going to be replaced with this b b b. Now this b is going to replace with epsilon, right? Now check with the terminal string. What are the terminal string? Check with the terminal string. See here, this is one terminal string a, then b, epsilon we have to leave the epsilon, then b, then b. So my, yeah, we are not going to read this epsilon, we are not going to read this epsilon. My string is a b b b. This is my string. So here we are going to generate the rightmost derivation. We are going to generate the rightmost derivation by using this string. We are going to generate the rightmost derivation by using this string, right? See. Now, next one is the leftmost and rightmost left and right recursive grammar, left and right recursive grammar. Here in a context free grammar G, if there is a production in the form x tends to xa, where x is the non-terminal and a is the terminal string, then it is known as the left recursive production. Left recursive production. Here that particular production must be in the form of x tends to xa. That particular production must be in the form of x tends to xa, right? Then that particular grammar is known as the x, here left recursive grammar, right? Here whereas x is the variable and a is the terminal, so that type of production is known as the left recursive production. If any grammar is having this left recursive production, then it is known as the left recursive grammar, then it is known as the left recursive grammar. Next, if any grammar, if any context free grammar, a context free grammar means G equals to VTPS. V is the set of variables, T is the set of terminals, right? P is the set of productions and S is the starting symbol. If any grammar is a context free grammar means it should be follow the properties of the context free grammar. Then these are the additional properties: left recursive productions and right recursive production. In a context free grammar G, if there is a production is in the form of x tends to ax, where x is a non-terminal and a is a string of terminals, then it is known as the right recursive production, then it is known as the right recursive production. See here, in the right hand side that particular variable should be present, right? In the right hand side, if the right hand side variable is present, then it is known as the right recursive production. If the variable is present at left hand side, then it is known as the left recursive production, then it is known as the left recursive production. The grammar which is having the left recursive production, that is known as the left recursive grammar. The grammar which is having the right recursive production, then the grammar is known as the right recursive grammar, right? Right. This is the derivations, right? Leftmost derivation and rightmost derivation. Leftmost derivation and the rightmost derivations which are present in the context free grammar, which are present in the context free grammar. Here just I am going to give the important points how we are going to construct in the leftmost derivation and rightmost derivation before concluding the class. Here in leftmost derivation we are going to replacing the leftmost variable, whereas in case of rightmost derivation we are going to replacing the rightmost variable. Here whenever we are going to derive any string by using the leftmost variable, we have to replace the leftmost variable first, then goes to the next element, whereas in case of rightmost derivation, whenever we are going to derive any string by using the rightmost derivation, we have to replace the rightmost derivations, rightmost variable first. Then here in this case whenever we are going to derive any string, we are going to use only one starting symbol, right? This is very important topic. You may get LAQs from these topics, leftmost and rightmost derivation. Whenever you are going to derive any string, you have to concentrate on the output string. By using this output string only, you have to decide which production is useful to deriving that particular string, every time you have to keep in mind that which production we have to use, and if we are going to use that particular production, then we are going to reach that end string or not. Every time you have to keep in mind that thing, right? With this I am going to concluding this class, leftmost derivation, rightmost derivation. In next class I am going to discuss about ambiguity in grammars and languages. This is very important topic. Definitely you are going to get one question from this ambiguous grammar, right? Thank you.